Loki stopped the recording by accident. So that's awesome. So I'll just upload that video and upload it later, I guess. Yeah. Whoops. Anyway. Also, like, I'm getting so sidetracked between these. Like, I think I started this at like 4 p.m. and now it's like 8 p.m. But anyway, right. So we have accomplished our goal. The aggregation of the log is no longer the concern of the individual functions. They produce their own messages, which are then externally concatenated into a larger log. But they're externally concatenated, which works, but yeah, it's verbose. So there's certainly something about, yeah, however, not sure about the middle abstraction, we have to abstract function, never mind. It's a nightmare of repetitive, error-prone code, but we are programmers. We know how to deal with repetitive code. We abstract it. So this is a banger quote that I will indeed be putting here, because it's awesome. This sums up how I define abstraction. It is the ability to make something tedious / repetitive / boilerplate less so. Yeah, at least like in terms of programming. Generally speaking, you know, if I take like a rock, and then, you know, never mind. If I get snow and make a snowman, I've abstracted the snow into a snowman, you could say, which isn't making it less like repetitive. It's just kind of giving it more significance. But like in terms of programming, like when you abstract something, you're abstracting a pattern, right? And like giving you a way to represent, because like it's like a heuristic, you know. At least for programming. Like again, like if I make my snow and turn it into a snowman, and then I say that's a snowman, then now whenever I see a similar thing, I can say that's a snowman, that's a snowman. Oh, what did you do today? Oh yeah, I built a snowman. You know, as opposed to saying, oh yeah, you know, I got some snow and I made some, you know, balls of snow, spheres of snow, and I put like carrots in it. Like no, I could just say it's a snowman by me labeling it and attaching the idea of a snowman to it, and then I can reuse that idea to just express an idea very simply, right? Very, very succinctly. Similarly, in programming, I can create an abstraction and essentially take something that is otherwise, you know, tedious or repetitive to explain, you know, or to write out, and then making it more concise. That's what abstraction is. That's why, like, even just the action of taking a function, right, that's like really long, and like splitting it into like subroutines or sub-functions, I guess, and like naming them rather than like having comments say what the thing is. Even just that is abstracting. You're abstracting your code to be more easy to process because you are literally chunking it. And in some cases, you know, you can make things less repetitive. Even just like the idea of making it simpler to understand. That's abstraction. And that's a powerful human ability. Yeah, it's how we make tools, it's how we have language, and actually, I'm just bullshitting. I don't even know if that's true or not. But abstraction is very powerful. You know, if someone ever asks you like, oh, what's you know, like IQ, right? Like the big thing about IQ, at least from the way that I understand it, is pattern recognition, and that links very tightly to the ability to make abstractions. So, if someone tells you abstraction is bad, abstraction, what they're saying is, I have a low IQ. I don't know how to use my human brain to make abstractions and make my life easier and make other people's lives easier. So, hot take. If you don't like abstraction, you might just be a bit low on the intelligence spectrum. They're turning the way through or high errors. 100 to 500 is a trivial for someone with a 6-figure income. Yeah, I was actually, I had a question, like, how do people just, like, throw $100 at streamers, right? But I guess that's a question that I would ask as a broke 20-year-old. So there you go. Can you... Are people capable of significantly improving their IQ over their lives from adulthood without changing, without like cheating the test or I don't know, gaming it. Like genuinely increasing their intelligence. I mean, it's the IQ is the intelligence quotient, right? Like the IQ itself is just a measurement of, like it's a way of measuring intelligence, but obviously it isn't the be all end all for intelligence. Like the IQ itself is a measurement. There's a reason it's not called well, okay, whatever, bro. I'm not a neuroscientist. Wait. Yeah, so this is really, so I have looked at this before because like I'm curious, and like it's actually really surprising. The answer is no. You literally cannot improve your IQ that much, which is like horrific. It's kind of horrific. I mean, I still hold the impression that like anyone, literally anyone, can do great things, but like literally like I believe anyone can improve their ability to, you know, abstract things, look for patterns in things, like just get better, you know, get smarter, more intelligent, whatever, through learning. Like that's the belief that I hold deep in my heart, you know. But then the science just says no, no, like your IQ is essentially fixed, which is kind of crazy. It's kind of crazy. IQ scores animals are physical over time, decades of longitudinal. The thing is though, is that because the average person doesn't try? Because like I don't really care about like averages, because I'm aware that the average person is quite mediocre. What really is interesting is for the people who do try, and like maybe they have access to resources, are they able to significantly improve? I'm talking like an IQ of like 100 to like 140 or 160, you know, like to really like improve, because like it's not a small thing. Like maybe that's why as well like IQ's been discredited over the years, because, you know, if it really is fixed and like even inherently biological, society is kind of fucked, because it means that like eugenics, is that even the right word? Yeah, it means that eugenics is low-key, like, it has a point. Okay, I'm gonna retract that statement because I do not believe in eugenics. What I'm saying is, it means that intelligence is biological, which means that some people are literally biologically intelligently superior, which is kind of crazy, and very not nice to swallow, if true. I really hope it isn't, because that kind of suck. So, you know, it's no shock that people are like, oh yeah, you know, don't worry about IQ. Who cares about like IQ's been very now like, especially recently, has been like very undervalued, you know, undercredited. Like, yeah, you got a high IQ, whatever, bro. EQ is where it's at, and it's true. You know, EQ matters, and there are other measurements of intelligence even. Like IQ is quite specific, but I mean, still, I mean, come on. Like it's pattern recognition and abstraction. Like you're talking to a programmer. Of course, I'm going to value those things like above almost everything else. And like it overlaps in so many different ways. Like if you do well on an IQ test, chances are you have a very strong ability to abstract things, understand things in ways that people can't. Like other people would just struggle to, and that's kind of like that's weird, man. Like I would like if everyone could just do it. But yeah, correlations around 0.6 to 0.7 across a lifetime. So does that mean like, what does that mean, correlations? Like that's how much they improve? Because that's nothing. You know, I mean like, if you look at like an IQ graph, I don't know. You know, like where the, yeah, I mean I know it's like adjusted every whatever. Wait, what? Man, 140 is high, actually. Like I said 160, but like that's like top of the fucking spectrum. I know that it is adjusted, right? So like an IQ that was like, I don't know, 100 years ago. Not that, well, did it exist back then? I don't know. But like that might be a bit lower now. because like it's built around the average. So like it's not an absolute score. It's like how smart you are compared to other people. I guess it makes sense then that IQ wouldn't change. Like statistically speaking, if everyone just gets smarter, then the IQ will just shift. So like an average IQ is just the average IQ, right? Yeah, I literally forgot about that. I hope that's the case, because again, like I do believe in improving one's ability. In terms of, okay, education, complex environments, health improvements, progress in childhood, when the brain is highly plastic. Damn. So I mean, at least children get it, you know? But like, if you're an adult, dude, like, I don't want to like reach adulthood and just like give up, you know? Brain training programs, lumosity, dual and back, etc. Reliably improve performance on the specified chain task. Yeah, but again, like, does it transfer to general intelligence? Improve mental recognition for IQ style items with a broader cognitive shift. Something needs to move the needle modestly and non-frontally, correcting severe nutritional deficiency. Okay, bro. So you tell me that if I treat my sleep disorders, I can gain a lot of IQ. Now that is something. Yeah, but like, it's like a few IQ points. Like, if I'm sitting at, you know, like 90, and like I want to get to 120, you know, like just up here, you know, like a few. Like, ooh, I got 4 more points and 94. Like, I don't give a shit, man. Like, put me up, man. Hold on. Is this because? Is it because of how IQ works? Okay, I don't think it is, but works statistically, or are people actually fucked? No, stuck with what they have. Yeah, it's known as age. Oh yeah, right. It's also like age based, right? It's known as age peers and often expressed as a deviation score. Yeah, you know, so like, but like when people say what was Einstein's IQ, like in what context, like in at his time, or like compared to people now, or although it's probably quite high. So improving your IQ partly requires getting faster than everyone else your age is actually getting from experience and moving target. Yeah. Regression, yeah. So I guess that's why like your IQ doesn't even change that much necessarily as you grow up. Like even like from childhood, like your IQ tends to stay roughly the same, unless you have like a particularly great teacher, I guess. But regression is to the mean. Okay. Children adoption studies. Oh yeah, with this too, like the kinship studies. Children adoption studies show heritability of IQ actually increases with age. 80%. Environment matches relatively less over time. I mean, 40% in childhood is still like pretty decent, but like if you're an adult, dude, 80% is like, yikes! Like that hurts. That hurts. And are these studies taking an average of people over time, or do they focus specifically on individuals who try to better themselves every day and learn new ways of approaching life? Well, I'm trying to find the light in the tunnel. Mostly the former, yeah, okay. Education and cognitively demanding jobs correlate with smaller age-related cognitive decline and sometimes moderately higher affordability. The closest evidence to your question, but it's correlational. Yeah, because like the people who are willing to do that will probably already have like that kind of thing, right? Cognitive reserve research, dementia. I don't care about dementia. I mean, I do care about dementia, and like preventing it, but like, damn, bilingualism, musical training, extensive skill acquisition. Some cognitive advantages. I actually studied that for my extended essay, IB. I looked at the effects of multilingualism, or the degree of multilingualism, on executive functioning skills, and the answer is not that amazing actually. I think it might get like a bit better at task switching, but that's like the obvious shit, you know. Like obviously, if you switch between languages, you're gonna be a bit better at switching between tasks than other people are. I myself am not bilingual, so. You know, maybe I can get a boost if I do that later in life. The honest gap in this evidence, nobody's run a rigorous long-term trial of highly motivated adults. Okay. So what you're saying is it's not confirmed. I'm just saying. should I be measuring my IQ as I go? Like I did I don't know if they were IQ tests, but I did like these tests that students do to see like what grade they should go in, what year they should go in, or like what classes they should take and like what level they're at, you know? I've done those tests. Like I get like I mean yeah, like the map test, but even like I mean more like the test where like they have you like look for patterns, you know, does the square go in the square hole, you know, but like obviously a bit more complicated than that. I've done those tests, and I don't even know what I scored, to be honest. I think my parents might have told me like a few times, but I forgot. Yeah, would it be worth seeing that? Like I'm curious just from like because like right now is a really good time because like I'm going into my second year of university. I'm studying like category theory, which is literally the theory of like abstraction, you know. So it'd be cool to do an IQ test now, like but like a proper one, and see later how I do on like a similar test, you know, to see if I improved from learning this kind of thing. Issue is though it's hard to test reliably. It's hard to get good tests even, you know. Like even just how you're feeling on the day can have such an impact. But I assume that like it shouldn't deviate too much, you know. Like if you get like 100 like let's say the deviation is like 5 points, you know. If you don't clear by more than 5 points in the next test anyway, then the changes probably weren't that significant anyway, you know. But yeah, I'm curious. I'm quite curious. I might ask my parents to slide those over so I can have a look. Not to glaze myself, but to kind of get an idea of where I am, no, where I was. I don't know where I am currently, and where and yeah, and something to compare later. Because I study computer science, but I am not. I am also heavily interested in psychology. If I wasn't doing computer science, I'd be studying linguistics, and if I wasn't studying linguistics, I'd be doing psychology. Actually, that's probably a lie. Actually, I'll probably do psychology second. Linguistics is like a fun like niche thing, or not niche, but like a fun like hobby. But like as an actual subject, I don't really care that much, because like it's like a history thing, you know. I care more about the present, and it's not really too much that you can do with linguistics, other than like training and like speech therapy, but that's a bit small scale. Oh yeah, this too. Fucking hell, like the race based IQ stuff. Yeah. But like the thing is, right, the cultural differences in IQ scores is interesting because it shows that the environment that you okay, I mean, first of all, just put it out there, I don't think that this is necessarily based on genetics. Of course it could be, I don't know. But I want to assume that humans are genuinely fairly equal. They're not equal, are fairly similar in their noggin potential, and that this is more of a cultural thing than a race, biological race thing, right? Because, you know, Asians have a very high achieving Asians are very high. I mean, like, typically, stereotypically at least, Asians have a high work ethic and a high study ethic, right? They want to do good in school, all that kind of thing. So, like, it makes sense that they are higher on average, just culturally speaking. Like, even if white and Asians were, like, on equal footing, just because Asians value that education, like, that much more, it would be higher, right? And then with whites, you know, let's say white is a baseline, just so I can kind of gauge. I mean, even here it is, right? Like, this is roughly the 100 point. And then with Hispanic and black communities, I'm guessing this is America, by the way. It can't be global, because otherwise I'd have more, like, a more diverse kind of range here. Like, Asian is very non-specific, given how Asia could encompass, like, China, Japan, and India, you know? Although they all are quite studious anyway. But then, like, with Hispanic and black communities, it comes to, like, opportunities as well. You know, like, if you don't get good education, opportunities, like, yeah, you're gonna be, like, the average population is gonna be lower. There's this one for, like, yeah, here we go, males and females as well. I believe this is a myth, I believe. I can't remember when I looked into this, but like on my feed for like a week or something, I got some stuff about this and like how it turns out this is actually a very fallacious study, and this isn't even a true, because like it's so perfect as well. Like, maybe it's true. I don't know, but for my memory, this one is a bit dodgy in terms of its validity. But it would imply that, I don't know, like the average male is closer in IQ than the average female, I guess. But yeah, I mean, this, yeah. Like, really the question is, what are people capable of? That's what I want to know. What is this? Gender percent by IQ score. Yeah, whatever. Lots of studies are a bit dodgy. A lot of them have ulterior motives. So, it's hard to trust a lot of these things in psychology in particular. And then also, like, even though they may look like they tell a story, there's more going on than you may realize. But yeah. Yeah. Maybe I'll look into that at some point. Why did I bring that up? Oh yeah, because my Claude I wanted to look at. Sorry, was I meant to do something else? No. Why did I even open Claude? I can't remember. Oh, because, yeah, abstraction and IQ. Yeah, fair enough. Yeah. Self-reported. That's interesting. I love how they have the self-reported. It's like this fucking spike at like 170, 180. Like, what is the general IQ range? Like, what is considered, like the top percentile? Like, does it even go to 180? 160, roughly. Top 0.003%, roughly 1 in 30,000. You know what's crazy? Actually, no, wait. Is that a lot of people? Hold on. University of Liverpool student count. That's not how you say that. Oh my god. So if you have an IQ of 160, you're like 1 in the, in the university. That's insane, man. That's insane. 130 is contextual for gifted. What's Mensa, bro? It's UK. Why? What do they do? What is Mensa for? Like, you know what's crazy? Like, usually people think of like being alienated by people who have high IQs, but a lot of the time, it's those individuals who do feel alienated. So like it seems weird to have like this like exclusive club, where like only the smart kids can go, the top kids can go, like meet each other and socialize. But it is really good for them because they get to interact with people who, well, first of all, can like understand them more. But also just like intelligence isn't as celebrated as it should be, at least in Western culture. So I believe Mensa's a UK thing. I wouldn't know because I have not lived in the UK until recently, but it's interesting. 150 scores get statistically shaky. Most kind tasks aren't normed to have high scores, so you're likely to distinguish say 160 from 175. Because IQs in 200s. Aren't from adult testing and aren't taken seriously psychometrically. Yeah. So top 1% is like 135. Holy shit, bottom 2%? 70 below. Traditionally the threshold for intellectual disability, yeah. A5, 1 to 15, average band. 68% of people. That's so many, dude. 115 top 16%. I wonder what it is for like universities. Like I said, like because like this is 1 in 30,000, right? But like, how about like 1 in whatever number of uni students? You know, people who like go to uni and do this kind. I mean, nowadays it's more bloated, but it's probably a bit higher, right? Anyway, it's just one. Anyway, yeah, it's just one form of measurement. Yeah. I wanna look into it. I wanna look into it at some point. Like that particular part of psychology, because I mean, again, I'm a programmer, right? So I guess I'm programming and doing things, but any field that overlaps with programming, I'm automatically interested in. Or I guess it's the other way around. Whatever field programming in overlaps with, you know. So I'm talking like linguistics is a huge one for programming language design. Psychology is a huge one, not just for, you know, AI and how the brain works. So that's also very cool, but just in terms of like software architecture, you know, how we reason about things, reason about code, you know, how we abstract things, how when you're designing programs, you know, you have to imagine the end user in mind, you know, and like user experience is such a huge thing that is obviously related to psychology. I mean, it is psychology, you know, like it's user experience. You got to tap into their minds, you know, and like get that, you know. Physics, I guess, if you're doing like physics simulations, like, you know, like that actual computing stuff going over there. I mean, there's computer science as well, which maths. I mean, this is literally, category theory is literally a math thing. I'm just reading a book about it that applies it to programming because that makes it easier to reason about. But like, yeah, I mean, programming is such an awesome field. And I say programming, not computer science. I say programming. Okay, computer science is not programming. Programming is not computer science. Programming is its own thing. Computer science is like, you know, optimization and like, fucking, you know, complexity and algorithms and proofs and all this. Programming in itself, like, is itself, like, it's an art of its own. Right over that. This is, however, not your run-of-the-mill abstraction. We have to abstract function composition itself. But composition is the essence of category theory. So before we write more code, let's analyze the problem from the categorical point of view. So, even like English, man, like the ability to like write, like to share these kind of ideas is so difficult to do. It's really underappreciated. Is it underappreciated? I don't know, but like it's like I do recognize how much bad writing there is out there. So like yeah, you appreciate the good stuff. The writer category. So I was expecting to see some mention of state monads at this point, but I guess not. I was thinking of like 10 signs that you're highly, you know, like 10 things that highly intelligent people do. Actually, I've actually seen those videos. I'm curious to look at them, just like kind of seeing like what people think. I mean, like they're very like buzzwordy and like very like, what's the word? Pseudo-sciencey, but I kind of want to judge myself on my own merit, you know? Because like if you have, what was it, like the 10 habits of highly intelligent people, like if you have if you can define those and like agree on those as like, yeah, like this means like you are intelligent in a useful way, then that can create a goal, you know, to strive for, which is pretty cool. Or like things that like, even like, I mean, if not adults, like at least children, you know, can be taught to have those habits, like questioning things and I don't know. They produce their own, or like not seeing things like it's black and white, you know. Don't take a term like state monad and like make it its own thing. Like actually understand what a state monad is when you use the term, and like don't just use jargon for the sake of using jargon. They produce their own messages which are then extremely correct in the logic. Okay, so I just read that. So my question was, it's interesting Interesting that the term state monad hasn't been uttered yet, hasn't been used yet. I wonder. Actually, yeah, does it exist here? State monad. It does. Where are we? Part 3? Are you joking? Oh my god. God, I wait, there's actually less chapters than I thought. I thought I was like 2% of the way. Man, am I actually? Yeah, more or less. No, I'm like 5% of the way. Yeah, so no, he does. Yeah, okay, bloody hell, dude, I'm so slow at reading. The writer category. The idea of embellishing the return types of a bunch of functions in order to piggyback some additional functionality. Is that why this book uses pigs, specifically for the piggybacks? Or does he just like pigs? It's very fruitful. Okay, we'll see many more examples of it. The starting point is our regular category of types and functions. We'll leave the types as objects, but redefine our morphisms to be the embellished functions. I don't like this term embellished, man. For instance, suppose that we want to embellish the function is even that goes from int to bool. What could there oh, right, okay, I see. To add like the logging thing. We turn it into a morphism that is represented by an embellished function. The important point is that this morphism is still considered an arrow between the objects int and bool, even though the embellished function returns a pair. But by the laws of categories, we should be able to compose this morphism with another morphism that goes from the object bool to whatever. Yeah, in particular, we should be able to compose it with our earlier negate. I mean, that's what I was saying, you know? Like, by having it in both input and output, you're able to compose it and pass a state. I mean, again, like, it's so simple, but, like, it just takes a second to, like, really appreciate. Obviously, we kind of compose these two morphisms the same way we compose regular functions, because of the input-output mismatch. Their composition should look more like this. Okay, so here's the recipe for the composition of two morphisms in this new category we're constructing. Oh, okay, so he defined a different way of composing. I mean, you could if you want to, but I don't know why you wouldn't just pass them through. I guess because, like, it's too... Could you return a function? I'm trying to think, like, how that would even work. Like return a function with like, the exact edit you want to make. Nah, but, like, you have to view global state to edit global state, right? Incoherent rambling. So here's a recipe for the composition. Yeah, execute the embellished function corresponding to the first morphism. Extract the first component of the result pair and pass it to the embellished function. That's that one. Concatenate the second component, the string of the first result, and the second component, the string of the second result. So that's here, right? And then return a new pair combining the first component of the final results. If you want to abstract this composition as a higher order function in C++, why are we still using C++, by the way? We have to use a template parameterized by 3 types corresponding to 3 objects in our category. You know what's cool about the language that I'm designing? It's actually, like, well, there's the syntax for it. Like, at this point, it's actually easier to express these kind of concepts using that syntax, because it's just kind of like everything that you would expect. Like, if I can take inputs that are a tuple, an output that is a tuple, why should they look different, you know? Like, why is my input, you know, just like 2 arguments, whereas my output has to be a pair, you know, bool, string, and like you can't even like give them names or anything. Like, those kind of things is what I try to fix in my language, and I mean, I say it just so happens, like, it is intentional. It lets you write code that matches the theory better. If you want to check this composition, as I mean, again, I'm not saying glows myself, but it's a cool, it's one of the main motivations for why I am designing this language, because I want to put my ideas on the paper. I don't want the language to limit the idea. Like, I know what I'm doing. You know, these mathematical theories have existed for a long time. Maybe not that long, but like fairly long. Relatively recent, you know, compared to math history, but yeah, let me express myself, I guess. Expression is the big thing. How expressive is your programming language? If you want to accept this composition as a function, you have to use a template parameterized by 3 types corresponding to 3 objects in our category. It should take 2 embellished functions that are composable according to our rules and return a 3rd embellished function. Lambda, so we got template ABC, writer. Did I miss the writer definition? No, okay. Did I? I probably did actually. Yeah, it's here. Why is it called a writer again? Because it includes the logger, I guess. Okay. So it's a writer of type C, USB-C, A. Wait, what? Is this returning a function pointer? I mean, like, a function? I haven't used a function. Yeah. Yeah, okay, yeah, they're functions. So, oh, right, because it composes and then returns a function. And who said that first-class functions don't exist in C++? No one said that, actually. Compose function B, writer C, A, B, and then just do the same thing here. It's pretty cool. Yeah. Go off. Now we can go back to our earlier example and implement the composition of 2 upper into words using this new template. It's cool how you can do that in C++, right? Like, would you even necessarily think, like, oh yeah, I can do that? Probably not. So, you know what? You know, C++. It's got the tools, you know? Of course, the syntax is a bit horrific, but it's possible. There's still a lot of noise with the passing of types to the compose template. Yeah. It would be nice if you could do type inference, but yeah, actually, can you not do type inference here? I mean, here they're using auto. No. Yes? Yes. But like, surely you can exclude them to some degree, maybe? Maybe not, I don't know. I don't know how strong C++'s type inference is. This can be avoided as long as you have C++ 14 compliant compiler that supports generalized lambda functions with return type deduction. Code for this code goes to Eric Niebler. Shout out. In this new definition, the implementation of process simplifies to this. Yeah, I mean, that's awesome. Like, if you told me that I can do this in C++, before that, I would have been very confused, actually. But now I'm like, yeah, cool. Awesome. That's my language right there. That's my boy. But we are not finished yet. We have defined composition in our new category, but what are the identity morphisms? Right, it's a category. And every object in a category has some kind of identity morphism. So it's what? Like the function from itself to itself? Is it not just the function that returns? Well, I guess it would just do nothing and then return like for the string output. It would just return an empty string, right? They have to have morphisms from type A back to type A, which means they are embellished functions of the form. They have to behave like units with respect to our composition. Yeah, literally. If you look at the definition of composition, you'll see that an identity morphism should pass its argument without change and only contributes an empty string to the log. You can easily convince yourself that the category you have just defined is indeed a legitimate category. In particular, our composition is trivially associative. If you follow what's happening with the first components of each pair, it's just a regular function composition. Which is associative. The second components are being concatenated, and concatenation is also associative. An astute reader may notice that it would be easy to generalize this construction to any monoid, not just the string monoid. We would use mappend inside compose and mmt inside identity. It was a plus in that. Yeah, there is no reason to limit ourselves to logging to strings. A good library writer should be able to identify the bare minimum of constraints to make library work. Here, the logging library's only requirement is that the log have model properties. Man, I gotta read more books and papers like this, dude. Like, I'm so used to reading like really shit grammar that when I see good grammar, it actually trips me up. Like, I've said this before. Like, you read something that is like actually good grammar, but you're used to seeing it done badly, so then your brain gets used to auto-correcting it. So when it sees a good grammar, it tries to auto-correct it, then realizes, wait, no, what? Yeah, no, here. In this case, it was, I thought this, because it's the has, right? Then there's writer in Haskell, which I guess is built in, or this is implementing it, no. Is there a writer abstraction? There's monoids. But that's different, right? It's interesting that he shows it in C++ first. I wonder if that's because this book is... Because like this book teaches you Haskell as well, as you read. It doesn't teach you C++. So it seems to clearly assume that you are already somewhat familiar with C++. At least enough to like know the syntax and whatnot. Like what a vector is, like what a pair is. So I guess that's why he starts with that. Just as well that I do know C++, or else I'd be very lost, because the syntax is not the easiest to wrap your head around. Hold on, this is passing M1, M2. Okay. Right, let's see the nicer version of this. The same thing in Haskell is a little more terse. Just a little. And we also get a lot more help from the compiler. Yeah, so here I'm just defining a type alias, an equivalent of a type def or using in C++. The type writer is parameterized by a type variable a and is equivalent to a pair of a and string. The syntax for pairs is minimal, just 2 items in parentheses, separated by a comma. Yeah. What was it in? Was it even a type here, or was it a function? Oh no, it is using. Oh wow. Okay, so to be fair, this is actually quite terse in C++ as well. I don't know why I thought it'd be more complicated. Like I've used similar, but the main thing is just this. Like the whole like template, like putting template everywhere is the most annoying thing. In Haskell, you just put a lowercase letter, and it's like okay. Or like you put it here anyway, because it's a type argument. I don't know why C++ can't do this. I assume it's like either a syntax issue with backgrounds, but no, because like templates have existed for like almost since the beginning of C++. So yeah, I wonder why it went that route. Because like it's like templates are probably the crux of what makes C++ so verbose. It's just the way they're written, the syntax for them. The type writer is parameterized by a type variable a and is equivalent to a pair of a and string. Our morphisms are functions from an arbitrary type to some writer type. Okay, we'll declare the composition as a funny, infix operator, sometimes called a fish. I swear this is literally. I swear this is an existing operator, right? It's a function of 2 arguments, each being a function on its own, and returning a function. The first argument is of the type a to writer to b. A to writer b, sorry. The second is b to writer c, and the result is a to writer c. Yeah, so we take a function, so well, it's a binding operator. So we take a function that goes from a to writer b, a function that goes from b to writer c, and then it composes them. Is that what that does in Haskell? Let me pull up the Haskell playground. What is this example though? I did not write this. Let me. I don't know if I need to import it or not, but let's do main io main. Yeah. So. Got a ping apparently. Also good resource. Covers a wide range of model categories, applications of quantum computing, and natural language processing. I've already bookmarked 2 things this guy sent. Abstract-based classes for category. Cooking. That's kind of cool, actually. Yeah, I think I've quite a while to go before I get to that stage. Well, yeah, what can I do here? Let me just try like something really basic. Like let's do 5 to 5. What's it? This? Yeah, that operator. If I run that, not in scope. Does it exist in Haskell? It's literally the Kleisli composition. Okay, so it takes a monad, by the way. I wonder if you'll call it a state monad at some point. But like this writer is just a monad. So how do I import it? Haskell fish operator. Library? Does it even exist? Control the composition. Yeah, that makes sense. What are these operators? Wait, Haskell has function composition, but this is for monads, right? But what are these symbols? That's 4 symbols right there. It's kind of weird how like it's that intentional? These don't even render properly. What are these symbols? That's so dumb. I didn't know that this language has so many operators, honestly. So here it is here. Wait. Oh yeah, B to this. Okay. Yeah, you know what? I'm not gonna think about it too hard. Okay. It's a function in 2 arguments, each being a function on its own and returning the function. Here's the definition of this infix operator. There are 2 arguments, M1 and M2, appearing on either side of the fishy symbol. Yeah. So it equals a lambda with x. Where's x coming from? I'm guessing x is the input to the first function. I mean, I don't need to guess it because it's right here. So yeah, so we have M1 pi to x. That gives us y S1. Wow, this is so Rust-like, isn't it? Haskell is so, Rust is so inspired. Z S2, y, and then yeah. I mean, same as C++, right? How does it C++ do it again? It really isn't that bad, is it? In C++, right? Like, the lambda syntax is probably the most verbose thing here. Otherwise, you have P1. I believe you could even use destructured bindings here if you wanted to. Right? So I don't know what standard that feature was added to. Maybe 20 or 17, maybe earlier. The result is a lambda function of 1 argument x. The lambda is written as a backslash. Yeah. So, I wish lambda was just like a symbol on keyboards. I mean, it is, right? Like, I can do alt ger L, I think? Nope. Yeah, so it's going to give me every Greek letter but lambda. It's hilarious. Like, you would think that computer scientists would, like, prioritize the one symbol that they use. The one Greek letter they use. It's probably here somewhere. Right? I don't know. I've not been able to find it so far. Or just switch to a Greek keyboard, but it'd be nice if we had more symbols. The let expression lets you declare auxiliary variables. Here's the result of the code M1. Yep, it's a pattern match. Ooh, hold on. Destructured bindings, actually. I wonder how that could work in my language. Hmm. Actually, yeah, I guess it's pretty simple, isn't it? Is it? You can't patch and match on destructured bindings, right? Like, yeah, like you do have to bind to everything. You can't like put in a value instead. Something like that. It's common in Haskell to patch and match pairs rather than use accessors, as we did in C++. Although personally, I do prefer accessors. Other than that, there is a pretty straightforward correspondence between two implementations. I'll also define the identity morphism for a category. Yeah, for completeness, let's have the Haskell versions of the embellished functions, upcase and 2 words. The function map corresponds to C++ transform. It applies a character function to upper to the string s. Yeah. Finally, the composition of two functions is accomplished with the help of a fish operator. Cool. Alright, so now on Kleisli. Kleisli Categories. You might have guessed that I haven't invented this category on the spot. Well, with a name like that, it's an example of the so-called Kleisli category, a category based on a monad. Oh yeah, we haven't actually talked about monads yet. I wanted to give you a taste of what they can do. For limited purposes, a Kleisli category has as objects the types of the underlying programming language. Morphisms from type A to type B, or functions that go from A to a type derived from B, using the particular embellishment. Each Kleisli category defines its own way of composing such morphisms, as well as the identity morphisms with respect to that composition. Later we'll see that the imprecise term embellishment corresponds to the notion of an endofunctor in a category. Holy jump scare! So, a monad is just a monoid in the category of endofunctors. Okay, I'm trying to think like if I can absorb anything there. The particular monad that I use as a basis of the category in this post is called the writer monad, and it's used for logging on or tracing the execution of functions. It's also an example of a more general mechanism for embedding effects in pure computations. Yeah, embedding. You've seen previously that we could model programming. How much of Haskell is truly impure? It's also an example of a more general mechanism for embedding effects in pure computations. You've seen previously that we could model programming language types and functions in the category sets, disregarding the bottoms as usual. Here we have extended this model to a slightly different category. A category where morphisms are represented by embellished functions, and their composition does more than just pass the output of one function to the input of another. Yeah. So, yeah, I forget that you can, I guess, define your own composition strategy. It turns out that this is exactly the degree of freedom which makes it possible to give simple denotational semantics to programs that in imperative languages are traditionally implemented using side effects. Do we need side effects in a language? Challenge ready? Wow, that's it. Okay. Cool example. A function that is not defined for all possible values of its argument is called a partial function. Yep, it's not really a function in the mathematical sense, so it doesn't fit the standard categorical mold. It can, however, be represented by a function that returns an embellished type optional. Yep. Optional was C++ 17, I think. So it should be well understood by the time this thing was made. I mean, I assume that's why he's calling it optional, because no other language does that, to my knowledge. Yeah. Like, a partial function can be made total by just having optional, right? Is that legit, actually? Rather than like making like type errors, just make it optional. Return optional. Like, if I have an integer that ranges between 0 to 100, well, yeah, I guess I can, right? It would just be tedious as hell, because I need to handle each case at runtime. So, like, I'm forced to handle it, but it's also, like, really annoying. Basically, the issue that Rust has, right? Like, there's a reason that Rust doesn't use result types for its standard arithmetic operators, because it would be too verbose, I guess, too tedious. But, like, can we abstract that away? I don't know. Well, I mean, I have an idea. So optional is valid value. I want to try implementing my own optional class. I did try and I failed horrifically in C++. I don't know. I mean, here's an example. Also, is it correct to define private before public? Because, like, the argument is that when people look at your function, they want to see the public stuff, not the private stuff. But anyway, so optional constructor. For example, here's implementation of the embellished function saveRoot. Yeah. Optional double. Right? So, like, rather than saying, like, the square root would give you a type error at compile time if the compiler cannot prove that it is. Although that's probably the better approach anyway. But, like, rather than having static analysis of your program and slow compile times, just do this. Just make a return option. And then handle it. The issue though, like, is you have to handle it. But, like, either way, you're gonna handle it, right? Like, if it's caught at compile time, then you have to handle it. If it's caught at runtime, you have to handle it. Like, all that changes is the way you write that code. So you've got a challenge. Construct the Kleisli category for partial functions. Define competition and identity. Implement the embellished function, say reciprocal, that returns a valid reciprocal of its argument if it's different from 0. Okay, well, that's fine then. That's pretty easy, right? Reciprocal is 1 over x, right? So if x is 0, then do not return. Compose the function saveRoot and saveReciprocal to implement saveRoot reciprocal that calculates square root of 1 over x whenever possible. I could try this, preferably in Haskell. Hold on. So, the Kleisli category for partial functions. Is this for partial functions with the optional? I mean, it must be, right? Otherwise I can't really do anything. I mean, it'd be the same thing, but just that if there's an error, then it would propagate, right? So should I try this then? So Haskell playground. What? Haskell playground. Right, so let's have our type. Alias? Is that a keyword? Is it type of using? It's type, isn't it? Yeah. Type. What should we call this? Partial Kleisli. So PK equals may. Is this with the logger, by the way? I'm going to assume it is. So let's have a string. Is that even a type? Are types capital letters in this language? Yeah, they are. String and... Yes, I'm putting string first, but I prefer that. String and... a, right? But would it be maybe? Like, if it fails, it's still locked, right? I assume. So let's put the maybe there. Maybe a, okay? And then we'll have a function, compose, which takes a function a to pkb to b to pkc to a function that goes from a to pkc, right? And let's define it. Holy moly. So we have two functions, m1, m2 we'll call it, and it would just be, I say just, without using the monadic bind operator here, we'll say let let's stir1, or like log 1 and log 1 and maybe let me just write. Yeah, so maybe 1 equals, no, in what? What's the syntax again? Yeah, no, it is equals. I don't need do, right? No, I don't need do. Equal m1 spaces, not tabs, and log 2, maybe 2 equal, sorry, m1 applied to, also, sorry, is that a tuple? Yeah, it is. M1 applied to some input x, yeah, okay, let me write it like this then. Nah. Oh no, because it because it returns a function a to pkc. Yeah. So this is right. So x is what's being returned here. So we pass an x, we pass it to m1, so that'd be a. X, sorry. So we pass an x. Do I need to... Hold on. Pass an x. That returns a string and maybe a. Or maybe 1, whatever. So then, if that's maybe 1, then I need to return like kind of early, but I can't do it in Haskell. So if it's maybe 1, if it's none, then I need to match it. Okay, so let's do this in, and then we'll have a case. Case maybe 1. Is that tabs or spaces? It's a tab. Why does it even let me do tabs in this? Oh, it does use tabs anyway. Okay, fine. Maybe 1. So if it's, what's the things here? Is it some? No, it's just and nothing, I think. So if it's just, y equals, right? I have to like refresh my Haskell memory here. Yeah, so just y equals. It's weird how equals is like overloaded here. So if it's y, then let, holy indentation, let log 2 maybe 2 equal m2 of y in sorry, the other case is just mapping nothing to nothing, by the way. Okay. So let's, yeah, in, and then return pk. How do I construct an object in this language? I just, yeah, I return a tuple, right? Do I even? I'll try. And then return log 1 plus log 2 as the first argument, and then for the second argument, maybe 2, right? I think that's correct. Let me see if this like compiles. Perhaps you intended to use lambda case. Is that an extension? Is it? Haskell case statement or expression. Holy documentation, dude. How do I trigger one? Is it a lambda or is it a? Oh no. Okay, so it's case like this, and it's of, and you use arrow. Yeah. Syntax things, run that. Okay. Could match type maybe A0 with string maybe C here. So would I include the log here? I think I do, right? I include log 1 to show that the other one didn't happen. So we do log 1. Do I though? Or do I only append log 1 if and only if both succeed? Ah, this is interesting. I'm gonna say include it. I mean, it doesn't really matter, does it? Compiled. Okay. I'm surprised that worked as well as it did. So the next thing to do would be safe reciprocal, first of all. So we'll do safe reciprocal, which is a function that takes an x or an a, whatever, and returns a pkb. No, sorry. Double to double. Yeah, whatever. Pk double. Okay. Safe reciprocal equals 1 over x, right? So if it's 0, it equals nothing. Okay, I'm gonna change my mind here. where it only shows a log. Yeah, but like you want the log to show how far it got, right? Surely. Surely. So let me do this then. Yeah, we'll have x whatever, and it'll equal something here. So we'll have safe reciprocal space. And then a case x of, if x is 0, then nothing. If x is anything else, sorry, I don't need a case here, do I? If x equals 0, then nothing else. I swear there's like a way to write this as well, like a different way to write this, but else 1 over x. I don't know if that's well defined. 1 over x like that. Maybe it needs to be like 1.0 over x. I'll find out, I guess. And we'll put this on its own line. How does white space work in Haskell even? Could a match maybe double with actual type double? Yeah, just. Okay, so if I print safe reciprocal of 5, I'll get 0.2. Yeah, that works. And then we'll do safe root reciprocal, so safe root first of all, obviously. So safe root takes a double, just pick a double, safe root. The cool thing is that they don't need to take the same type, but here they just happen to, so it's fine. Yeah, so again, if it's, this is rooting, right? For roots, it's if it's less than 0. So we'll take x again, and we'll say safe root with a space, new line, and we'll say if x is less than 0, then nothing, else take the square root of x, just the square root of x. Could use pure, but I don't see the point. Okay, so let's print both here. So safe root of 139. That's not right. 169. 13. Cool. Both work. And then to compose them, I would say safe root reciprocal, right? So safe root reciprocal. Do I really need to define it? Well, I can't, right? I'll just say safe root reciprocal. It's a, yeah, just a double to a picky double. Looks pretty inconspicuous, but what we're doing is, it is the composition. So we're going to compose safe reciprocal and safe root. But I think safe root comes first, right? It calculates square root of 1 over x. Oh no, it doesn't. Square root of 1 over x. Ah, why? It's kind of hard to test. Well, not really actually, but yeah. So it'd be this one first then. So first reciprocal and then the root. Am I wrong? No, that's correct, I think. So we'll do that, and we'll run that to see what happens. Okay, so let's try this then. Print safe root reciprocal of 1. I'll do the reciprocal first and then the root. So give me 2. So I'll pass in 0.25. And that should give me what I want. Wow. That worked. That worked. So let's do like 1.0 over 13, I think. That should give me, sorry, of 169, and that should give me 13. Cool. I'm surprised. That went surprisingly well. Yeah, so I'll copy this. Just 2.0. And I'll try something else as well. So let's say I want to print square root fails if less than 0. So let's do -1. Right, pretty straightforward. I believe I need to bind this like so. I should get nothing. And indeed I do. Cool. So I'll copy this into my NeoVim. What's this, 4.4 was it? Challenge. Yeah, paste that. Haskell. Yeah, good. I'm quite proud of myself for that. There's the code. Oh, I'm not printing the log, am I? Well, no, I am. I just ignored it. Yeah, so it calls both. So here we see that this fails as safe root, right? So if I call this instead, so this one succeeds both. If I call it instead on 0, right? Then it only calls the first one. Yeah. So that's quite an important distinction there. So I'll put these on the scene, just a different line. So we got that. We got that. And we got this one as well. Wow. Is this how Iron Man felt when he discovered time travel? How did the hash I get there? Like, I swear I didn't put that there. Cool. Congrats. So that's cool. Yeah. Okay. So what did we learn in that section really quick? Not much. But yeah, that you can pass around like that. Okay. Cool. Moving on. Products and co-products. Oh, okay. So I already know about this. Holy moly, there's a lot of chapters to this one, sub-chapters. So what's next? We got simple algebraic data types. Then we got functors, functorability, function types, and natural transformations. And that's part 1. Part 2 goes like free monoids and whatnot. Okay. Nice. I'm liking this. So far this book has actually been really good. I would rate it so far. But we'll see how far it takes us. Construct the Kleisli category for partial functions. Yeah, so I assume that was a partial function. Because you have to represent it through this, right? Yeah. So I assume you were meant to use optional there. Should I try implementing this in C++? Just to like I kind of want to, just to kind of get to see how that works properly. Because with Haskell, it's quite easy to fall on like the features. For C++, it takes a bit more thought to actually be doing it properly. So let me go compiler explore with Godbolt. I'm taking a look at this. So I got pk string and maybe. My compose function does this stuff. I could definitely rewrite this to be a lot nicer, I think. I could easily make this abstraction. I think guard already exists, right, in Haskell. but like let's say I did like let's say I did x, sorry, it's like or nothing. Takes a condition, a Boolean condition, so a bool, and a maybe a, and returns maybe a. Yep, and I'll do so condition or nothing. I believe I can do it like this. I believe I can define functions like this. Result, let's say, whatever, equals if condition, then nothing else result. Ooh, let's have without the a actually. Yeah. And then I can abstract this away to say x equals 0. Or nothing. This. That works, right? Possibly incorrect indentation or mismatched brackets. Funny how the error comes here. Oh, because of the hashtag. Yeah. So like that just massively simplifies that. Same thing here. X equals 0, x less than 0. That entire thing just becomes or nothing square root of x. Cool. But anyway, that's not important. So here we have C++, also with SimD. Let's take, well, what do I need here? I need pair first of all. So standard pair, holy moly. Utility, okay, hashtag include utility. We'll say using PK, which is short for wait, why is it PK? it should be MK for like maybe. That was the, yeah, it was supposed to be maybe. Why is it PK? Like maybe Kleisli. Yeah, let me just change that in my notes. PK with MK. Yeah, maybe Kleisli. Okay, so using MK equals a standard pair. Should I use, yeah, let me using namespace ST standard. Like for this like particular like example, it doesn't matter having that pair. It'd be string and T, right? Well, I'll say A. So templates, type name. I don't know why they use class. I guess it's just like a preference thing, really. Template argument is invalid because I haven't included string. Somehow that isn't included in utility. Quite surprised actually. Okay, let me go to Vim mode here as well. Take a semicolon. Yeah, just missing a main function. Okay. I could be petty here and define these differently, but screw it. Okay, so then we're using that. Then we need our compose function. So auto, well, first of all, there's templates, right? So there's type name A, B, C, and it'll be auto compose, which takes a standard function so it's A to our monad, right? To our maybe K. Wait, how does that function work? I think this is a return type. So it return mk of A, I think, and then this are the arguments, right? So it take A as an argument, and then function, because we don't need standard function. I'm in Vim mode, forgot. mkb. Sorry, no, it takes A and returns a B. Yeah. So we do that. This will return a C. It takes a B. And then this returns a function mk C from A. Yeah. Holy indentation, dude. Okay. What's the issue? I expect a primary expression before that. Why? But this would be M1, M2. I'm confused. What's wrong? I mean, am I even including functional? But it's not saying that it doesn't recognize. Gaze, had a function. Yeah, functional, yeah. Void int. Okay. So it's actually here. Okay, you should get a return type error now. Oh, this is also wrong. Okay, good. Now I need to actually do it. So first we can do auto destructured bindings here. We'll say, I mean, it's a tuple, so like whatever, it doesn't matter. If it were a struct, I'd be a bit more strict about this. So we'll have log1 and maybe 1, right, equals m1 called on so it's returning a function, so a lambda, where it passes m1, m2, right, and it has an argument x of type A, so AX, okay, and then that's the body. Expected semicolon before closing brace here. Yeah, so we're going to pass x into that. I believe the compiler doesn't like give you as much help in terms of like the actual type errors, but right, so this works, the destructured bindings, and we say, yeah, so we'll just say that if not maybe 1 dot has value. sorry, this isn't even, yeah, sorry, this should be an optional A. I'll use the built-in type here, no point in making my own. So if maybe one doesn't have value, then return mk. Construct mk, right? With log1 and standard. What's empty? Null opt, I think. Yep, null optional. Otherwise, and this is a nice thing where we can have the early returns. Otherwise, log2 and maybe 2 is m2 of x. No, m2 of the dereference maybe y. That's right. Should I be explicit here and say like auto y equals maybe 1? Doesn't really matter, does it? I'm gonna say no, just because I keep it explicit. Also, this would be const. I mean, it doesn't matter, but just to be consistent here. Actually, no, screw const. Doesn't do anything. Right, and then we'll, if this, so if not maybe tutor has value, then return mk with log1 plus log2 null opt. Otherwise, return mk with same thing, but dereferencing maybe 2. I don't need to dereference it though, because it's already wrapped in optional, funnily enough. Yeah, I don't even need to like do that actually. Yeah, that works. Yeah, could probably organize this a bit nicer, but there's the main idea. So let's use this in a function. So we'll say auto, what's it, safe reciprocal, very safe reciprocal, holy moly. It takes a float, right, we'll use double here, a double x, oops, and returns a optional double. Okay, automatic parentheses insertion, to like that. We'll say if x equals 0, then return null opt. I'm aware that I can use empty brackets, but it doesn't make sense for maybe type. And otherwise return 1 over x. 1 over x, so we don't get any implicit narrowing. Return type sorry, is it even recognized here? Where is G? Oh no, it's at the top. GG? Okay. Include optional, right? It's weird because I used it just now and didn't flag it. So that can't be the case. That was the case. Okay, it's not corrected. Let's go ahead and do it auto main, just a main function, sorry. And we'll say standard. I'll just see out, just because print takes a long time to compile on this thing. Safe reciprocal. Okay, there's no way to print. Maybe that's the issue. I mean, an optional type. Okay, fine. So I'll say if auto maybe results equals safe reciprocal. Say optional. of 169.0. If maybe results dot has value, if not even, then standard cout the value, no, I'm sorry, nothing or empty. No, the return type's an MK, isn't it? Yeah. Okay. So first things first, include IOStream, ABCDFGHI, yeah. That's the first thing. Second thing, this should return MK constructor. We're going to pass in the name, safe reciprocal, and actually, yeah, put it on a different line, and say x equals 0, question mark, null opt, otherwise 1.0 over x. Two different types. What? What are the types? Const, standard null opt, t, and double. Yeah? It's an optional double. It's kind of the point. That's weird. Let's work with that. That's strange. Why doesn't that work? Okay, well, I'll wrap an optional then. Huh. Weird edge case with the ternary operator, I guess. Bit strange. But yeah. So if it does not have value, then return empty. Okay, this isn't even correct, right? It's MK. No, auto, and we'll use these destructured bindings here as well. So we're going to have the log, and we're going to have the maybe results. Okay, and keep it simple. Let's just, man, dude. Should I overload? I don't want to overload the whole formatter at this point, dude. Like, I'm too lazy for that. So let me just go to the beginning. I'll include format at least. And let me format the string so it's a tuple. Actually, I'll use this syntax. Yeah, so I'll say here. Like that's annoying. Whatever, I'll do this. I'll do here with a log, comma, empty. Okay, and pass in log. I don't know why I'm not just compiling this locally. Save a lot of time. So let me Okay. Otherwise, standard cout. Still log, but also the value that we don't know yet. So log and maybe results. Okay. Sorry, this is reciprocal, not square root. So let me pass in a different value. Let's do, I don't know. Yeah, 0.25. Should be 4. Let me not compile with 26. Yeah, that's 4, good. And if I compile 0 with 0, I should get nothing, or empty. Six sev. How have I got a 6 sev? Just quietly. How have I got a 6 sev? Oh, because it calls it afterwards. Yeah, fine. My fault, bro. Yeah, empty. Okay. So let me just change this actually. We'll have none, and this will be some. You know, so kind of like Rust style. I could do this in Rust, but whatever. I do like C++. So there's none. And if I do this with 0.25, some 4. Hell yeah. So let's do the other function. So auto safe those roots, right? What's it called in the challenge? Safe roots. Okay, so safe roots takes double X as well, returns MK double. Sounds like a Mortal Kombat game. Return MK safe root space boom bap pow, and we're going to say if X is less than 0, that's a nullot. Otherwise, optional. Ooh, okay, hold on. Standard square root of X. I need to include C math. Okay, this is where using namespace standard actually might cause some issues, but what? C++ C root. It is square root. Is it a different function? The square root f, I guess. Oh, for fuck's sake. Go away, go away, go away. No, it's overloaded. Until 23. Since 23, oh yeah, it's just general. That's fine. And it's only context since 26. Holy glare on my face, dude. In C math. Yeah? What's wrong? I misspelled it. Okay. Hilarious. Look, R, G, boom, Should work now. Yeah, my bad. Should work now. Okay, so now I can just say that auto safe div roots reciprocal is the same signature as the others, but I simply return compose. I'm going to compose safe reciprocal first. Reciprocal. What reciprocal and safe root. I'm aware that these might be backwards conceptually, but it doesn't really matter, does it? Doesn't really matter. And then just call X on that, or call that on X, and it should be good to go. Mismatched types. Why? Returns an MKB but takes an A. Looks correct to me. Let's actually read this out. It thinks it's MK double at double. Are you sure? That looks right to me. Standard function, standard pair, basic string char, optional. Dude, I hate template error so much. Standard function or standard pair of basic string char and optional. Because it doesn't treat the function pointer the same or something? I guess. Oh, because it's a function pointer, right? Hold on, how do I do this? Do I need to like dereference it or something? Because it's a pointer. This goes beyond what I'm used to in C++ at this point, because I don't really use function pointers. Okay, I'm gonna cheat for this one because I cannot remember. Okay, he does his auto, to be fair. But this is what he did before. Do you have to include the type parameters if you do that? String, string, vector string. So double, 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 to be fair. Let me try it with specifying the type arguments. So compose double, double, double. But there should be deduction for this. What was a no semicolon? Yeah, it doesn't like this. That's weird. Okay. So if I use auto, will it work? Like, I don't want to because it's not very clear, but the return type is also auto, right? The return type is also auto. Does it need to be const? No, it's already const, it's a function. This is like a function as like a variable as well. Funky. I wonder if that's necessary. Yes, like auto. Yeah, like literally everything's auto. Nah, same issues before. So let me go back. I'll add the double. On line 21 here, class template argument deduction failed. No matching function for call to pair tuple element 0 pair what? Where does 0 come from? Hold on. This returns a function, right? Let me be that explicit. There's an error here. Okay. Bit strange. Like, do these issues resolve themselves if I use a variable instead? Const auto compose equals no. Why is it auto const? Does that work? Yeah, so the compiler doesn't complain about this. I don't know why it didn't accept it. But okay, fine. Yeah, same error. Exact same error. Am I missing something? Class template argument deduction failed. How? Like, should nullop just be whatever it needs to be? Can I like just send an optional empty? I don't know. Type of, is that a thing? Type ID? Type ID, no, decal type of X, right? Okay, I don't know what's going on there. So if I go all the way back, if it lets me. Yeah, and just change this to standard optional a empty. Okay, that's weird. Yeah, okay. C++, guys. So can I move this? Because I'm in C++ 20. No. Weird. Okay, fine. So I'll make it explicit. Whatever the case, this should work now. So let me try the same examples. Kind of move that back as well. So we got safe root of 1.0 over 1.69. Okay. So safe reciprocal of 1.0 over 169.0. Yeah. There's no shadowing, so I'll just do this for convenience sake. That should be fine. Yep. Just paste it twice. Do different values. Go ahead and flush the buffer while we're at it, for no reason. Yeah, so we had 1.0 of 1.69, then we had negative 1.0.169, and then just 0. Okay, that's what we get. Perfect. Perfect, perfect, perfect. So you get sum 13, and for the rest we get nothing. So let's go ahead and just copy paste these into the code. Can I speak? Let's copy paste these into the code. So this here is this. This here is this. This here. Whoops. Is this. Okay, and cool, copy that, put in my notes. So Haskell attempt and my C++ attempt. Probably learned more C++ there than I did actual like theory, but yeah, maybe that wasn't really worth it. Geez, can it copy paste, please? I guess it didn't go to that. Let's do this. Paste. Oops. Scale attempt, equal plus attempt. Yeah, cool. There you go. Let's run this, send this in the C++ Discord server to flex my new learning. Where would this go? Math? No, that's math homework, literally. Yeah, probably here to be fair. Template metaprogramming. It'd be here, right? No, but that's like no, that's like reflection. Comp sci. Yeah, here we go. Upload as a file. Partial. What's it? Partial. Kleisli. Partial Kleisli composition.cpp. Execute. Pretty cool. Oh, why is it so fast? Okay, probably have just like abstracted this to be fair into a pattern instead of like repeating it like this, but whatever. FBX, and that's good to work with. Better than a custom format, of course. Okay. So that was Kleisli Categories. Right, cool. Little fun exercise. Products and co-products. So I already know what these are anyway. A product is a product type is A and B, co-product is A or B. Or B, think of it that way. Because that is basically what it is. Chapter 5. Alright. We're not moving quickly, but we are moving nicely. The ancient Greek playwright Euripides once said, "Every man is like the company he is wont to keep." Every man is like the company he is wont to keep. Okay, he was defined by our relationships. Right, so company is in like actual company, not the big tech, whatever. We're defined by our relationships. Nowhere is this more true than in category theory. I'm surprised this book doesn't like start with quotes on each chapter. If we want to single out a particular object in a category, we can only do this by describing its pattern of relationships with other objects and itself. These relationships are defined by morphisms. There is a common construction in category theory called the universal construction for defining objects in terms of their relationships. Okay, one way of doing this is to pick a pattern, a particular shape constructed from objects and morphisms, and look for all its occurrences in the category. If it's a common enough pattern and the category is large, chances are you'll have lots and lots of hits. The trick is to establish some kind of ranking among those hits and pick what could be considered the best fit. Okay, low-key, my head hurts. I'm gonna stop there for today. But good. Now I know about Kleisli Categories. Right? Not so much on, you know, to note take, but like this idea is pretty cool, then implementing it is pretty cool. To be fair, it really wasn't that complicated. But just going through it was a bit fun, so. Yeah. Alright. So what can I take away from that today? I guess that you don't have to like return all of the state and pass the state. You can just pass what you want the changes to the state to be, and it works for any monoid. To be fair, right? Any monoid will. I guess that I mean that's why a state monad is A to AS, right? Or A to SA. A to S and A. Or like value to state and value, because you don't need to take the state as input, as long as the state like it's easy for like a string, right? Because you just concatenate the string, like that's the monoid. But what about if I have like a map, or like a dictionary of variables, right? Like how do I use that in a monoid? I am not so sure. It's like you can't just concatenate it, like you need to change it, literally. Although I guess functional programming languages don't have, I mean like since they don't have mutation, then you can't change a dictionary entry, like you do just add a new one. Can you remove them though? Can you remove a dictionary entry? Because that's also fairly important, right? Yeah, and shadowing also exists. So yeah, I don't actually know how that works. But hey, a question to answer in a later discovery. So this is 2 recordings because I did the first one by accident, but yeah, nice. Subscribe for more category theory discovery and research, and hopefully I can finish the first chapter. I mean, I think there's like 6 more chapters left, right? I just finished chapter 4. Yeah, I don't know. Progress will be pretty slow. I'm a pretty slow reader because I stopped to take notes and think of things and try things, which is good, but it does mean that I do not get through things particularly quickly. I do look forward to starting uni again. I wonder like if being in the atmosphere can like get me back into the flow of like doing that. Also, honestly, like it would just be so helpful if I had people to talk to about these kind of thing, so that I could learn something and then come back and like share my discoveries, whatever. But unfortunately, you don't get a lot. Well, this is an extremely niche topic. I mean, like this is the biggest community for programming language development, and it literally has 7,000 members, which is like nothing, really. Like in like for something that's like meant to be this like big and like important and interesting, it's like it's really niche. It's really quite niche. I mean, compare that to like, I don't know, the C++ Discord server has 64,000 members, 65,000 almost. The Rust server has 70,000 members. I'm in a YouTuber server, Shy Guy Mask. His has 5.8 thousand. I guess that's actually less. Okay, maybe I'm discrediting how niche it actually is, but yeah, it is quite niche. So it's not very often you find people who actually are interested in it and will talk about it. And in my university, definitely, I've not found that so far. I mean, most people are interested in like AI, cybersecurity, You know, like we don't even really have modules on programming language theory and design, and like the maths of programming languages. Like we have like the maths of computer science, you know, with set theory and algorithms, you know, and whatnot. But like not like this kind of maths, the good stuff, you know, which is unfortunate. But hey, you never know. Maybe I'll meet some people one day, or I can inspire some people to actually have a look at it, and maybe they'll find it interesting. But yeah, to be continued. In fact, tell you what, because like speaking of, uni starts, I think like in the last week of September, like 21st, so I still have over a month left before uni starts, which means in the next month, surely I could finish the book. Because like, let's say there's 30 chapters, which might be correct. Roughly 30 chapters. Well, no, because that's like 30 a day. Okay, maybe not finish the book, but like at least finish like the first section and the second part as well, probably. Right? But I need to like do like at least a chapter a day, which probably isn't that likely, to be fair. But I'll see.